everyone. Today we are going to discuss about the PSPM past year question, which is in our physics lecture book, page 80. So the question shows a 2 kg block is being pushed along the rough horizontal surface by a force F equals to 30 N at the angle 60 from the normal. So the question A asks us to sketch a free body diagram for the block and use common symbol for each forces. So first we need to know that force can be classified into 5 types, which is weak, tension, friction, normal force, and external force. So after that, we need to use X and Y axis. After that, we need to draw a dot at the middle of the axis to represent the object. So first, the question tells us that this block is 2 kg, which means there's a weight on the block. Then the weight is always point vertically downwards. So we can draw like this. And next, after we know there is a weight, and the question told us that the block is placed on the horizontal surface, so there is always have a reaction force, which is N, that always perpendicular to the surface. So it's perpendicular to the surface. And you can draw like this. And next, the question told us that the block is being pushed. The keyword push told us that there is an external force applied on the block, which is the F. So we can draw the F from here to here. And lastly, since the surface is a rough surface, which tells us that there is a frictional force that always opposes the motion of the object. So here is the friction force.
Now let's move to question number 2 of this exercise. If the block moves at constant acceleration 0.5 meter per second squared, calculate the coefficient of the friction. So by using the free body diagram from the previous part, we'll use the diagram to assist us in this part of question. So constant acceleration 0.5 meter per second squared means that the block is moved towards right hand side because the force is exerted on the block from upwards and towards the right hand side. So the acceleration will be towards right hand side, and we can know that motion towards right hand side is the positive one and the other side will be the negative one. Because of the block is moving on the rough surface, so we can know that the acceleration 0.5 meter per second squared is actually the acceleration of the block in X component, because the block is moving parallel to the surface and it won't jump over the surface. Yeah. So now we have to know what is the coefficient of friction. We can get coefficient of the friction from the formula F equals to mu normal. The F means frictional force, and the N indicates the normal force. So the coefficient of the friction is actually the mu. This symbol mu, that's the coefficient of the friction. The question asks us to find out the mu. Weight will always equals to mg, and the force, external force, can be resolved into 2 parts, which is x component and also y component. So this fx will equals to and the force equals to 30 and So we know that f of x will be 30 sine 60 because it's the opposite of the theta of the angle, while fy will equals to negative 30 cos 60 because it's toward downwards, so that's why it's negative. The value is negative. So now we have all of this information except normal force and also the friction force. So this is what we are going to find out in this part. So by using the formula F equals to ma, which is obtained from the Newton's second law of motion, force is always directly proportional to the product of mass and acceleration. We can resolve this into two components, which is x component and also y component. So for x component, we know that all of these symbols in the free body diagram actually represents all the forces. So actually, they are all forces. So let's look into x component first. So we know that the sum of all forces in x component will equals to max. And the acceleration ax, we know that it's the constant acceleration 0.5 meter per second square. So we have to resolve the fx first. We have to substitute all the formulas inside. So we know that fx from this diagram, we know that fx consists of f sine 60 plus negative fx. The fx is negative value because it's pointed towards left hand side, so it's negative, and equals to max. So now we can substitute all the values inside. So we will get 30 sine 60 minus fx equals to m 2.0 times 0.5. And we know that friction fx is also equals to mu n. So by using this formula, we can substitute mu n inside this formula and we will get 30 sine 60 minus mu n equals to 2.4 times 0.5. And after we make the mu n to become the subject, we will get 24.9808. So mu will equals to 24.9808 divided by n, and we get our first equation. This is the first equation we get from the component x. Okay, so now we get the first equation from our x component. And then now we are going to get the second equation from the y component. So in y component, we have normal force, Fy that we resolved just now. So from the equation F equals to ma, we have the sum of may, and the force in y component n minus w, because w is always toward downwards, so it's negative, and also minus f cos 60 because it's also towards downwards, and equals to may. And now we know that w equals to mg, so we have to sub this into our formula, and we'll get n minus mg minus f cos 60 equals to may. Okay, now we can substitute all our values inside. So n is our unknown because we don't have any magnitude of it. So just leave it as n minus m, which is 2 kg, times g equals to 9.81 minus 30 cos 60 equals to m 2 kg, and our ay will be 0 because the a in this situation only consists of x component and don't have y component because the block is moving parallel to the surface towards right hand side. So we only have ax, and so ay will automatically become to get n equals to 34.62 Newton. And now we get our first equation. So the coefficient of friction mu will equals to 24.9808 divided by our normal force, which is 34.68, and then we'll get mu equals to 0.72. Note that mu is the coefficient of friction. It doesn't represent the force, the friction force itself. So it doesn't have any units. So the answer will just be 0.72 without any units. Okay, so that's all for today. Thank you so much.